Hello and welcome to Optimizing Your Cloud Spend, Effective Strategies for Cloud Cost Management. Today's webinar is sponsored by Harness and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech and I'm excited to be your moderator for this special event. Now, before we get to today's important content, we do have 4 housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh will fix most audio, video, and slide advancement issues. But if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to a link to get started with Harness. Now, third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. Now, finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. After the event is over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. Okay, with that housekeeping out of the way, let's get to today's timely discussion. It's my pleasure to introduce you to our presenters today. We'll be hearing from Ravi, who's Director of Product Management at Harness, and he'll be joined by Rohit, who'll be running a series of demos. Ravi, welcome. Thanks for being here.
Thanks, Scott. Great to be here.
All right, well, I'll get out of your way. Take it away.
Awesome. Thanks again, Scott. And hey, everyone. Good morning, good evening, and welcome. Today's session is about optimizing your cloud spend with effective strategies for cloud cost management. But before we jump into the topic, let's talk about an initiative that we've started at Harness called the FinOps Excellence Collective. So what is the FinOps Excellence Collective? So it's a group of FinOps, CloudOps, and engineering leaders collaboratively reshaping the landscape of cloud cost management and optimization across industries. And so why we started this initiative is that to provide a forum to exchange ideas, best practices, challenges in FinOps. And so practitioners can get to learn from their peers across industries and company sizes, and it's been extremely valuable to everyone so far. Now, that's the benefit to the members, but also for Harness, we've started this to empower this community, but also all of the learnings and insights, as you can imagine, make their way into the Harness CCM product. Now, we've already hosted events across 11 cities with over 150 members. We're close to 200 members now, and this is across the US, Europe, and in India. So you can visit finops-excellence.org to look at a list of all of the upcoming events in your city. We have a whole bunch more planned for 2024, so if you're interested to join, we'd love to host you. Now, all of the learnings from all these recent events really came down to 4 key causes for cloud waste, which brings us to the topic for today. So let's talk about what they are and how Harness CCM can help. Now, first up, you can't improve what you don't measure. So getting a hierarchical breakdown of cloud costs across your organizations itself can be hard. Now, this is because of distributed teams and departments, lack of cost attribution, including costs of shared resources. So how can Harness CCM help with this? Now, our granular cost reporting that is built on first-class BI and analytics platform with your cloud cost data as the source, including for shared costs, enables simple showback and chargeback. And on top of that, our anomaly detection lets you proactively detect and remediate unexpected cost spikes. And our budgets, even our cascading budgets, helps you make sure that teams are well within their planned spending limits. So let's take a look at this in action. Rohit, over to you for the demo.
Yeah, let's get right into it. So here's an overview screen of Harness CCM. As you can see, we are pulling in costs from all three major cloud vendors, and we also offer like deep Kubernetes and ECS visibility. So let's take a look at how that looks like. So this is a cluster view where we are pulling in costs from various clusters, and we can drill into a specific cluster and sort of get into the weeds of it by grouping it by different constructs like namespaces and nodes and workload IDs. So I want to look at the specific workloads of this specific cluster, and as you can see, Harness gives you like a detailed breakdown of all of the workloads present. What is the idle cost, what is the storage spend looking like, and so on. And you can get down to the granularity of drilling into each of these workloads as well. So for example, if I click into this platform workload, I can actually see its utilization of its resources of CPU and memory over time. And when it comes to a hierarchical breakdown of costs, this is a perspective where we are bringing in costs from all these different cloud vendors, and we are grouping it and normalizing it by products. What we also have is the functionality to break these costs down by what we call as cost categories. So cost categories are essentially a way to organize your costs to constructs that are closer to the business. For example, departments or teams or line of businesses. So in this case, I'm just breaking these costs down by departments. And as you can see, like based on the definitions of the departments, the overall costs have been broken down by the different departments that we have. And like Ravi mentioned, we also offer, we tie all of this together with budgets. So you can set a budget, which we've set to 650K in this example. And if you drill into the budget, we have the spend till date, what is the budgeted amount, what is the forecast looking like, and we have a detailed analysis of the variances of the budgets over time. So, drilling back to the perspectives, we also offer what we call these little dots you see here are what we call anomalies. So, anomalies are essentially a way for us to detect any kind of spiky spending and get it to the notice of developers to take immediate proactive action. So, as you can see here, we have a list of anomalies that we have. We can drill into one of this and see what's going on. So as you can see, I just clicked on the anomaly and it automatically applied all of the filters related to that specific anomaly, which product it belonged to, what project it belongs to, and the SKU. So as you can see here, there is a cost spike on the 23rd, which the system flagged, sent a proactive notification to the developers, and they took action and it got fixed in the subsequent days. We also offer a very comprehensive custom dashboarding solution. It's based on a popular BI platform called Looker, and you can essentially create all these different visualizations with various trends. And you can see here like an overall FinOps dashboard where we have costs coming in from GCP, AWS, and Azure. We also support a high degree of customization in custom dashboards. So for example, we have added like a mean and a moving average trend line on top of the costs. We also support forecasting, and we also support proactive alerting that you can set up on top of these dashboards. So we offer like a comprehensive list of these features to be able to solve for all of the key challenges that Ravi mentioned. Back to you, Ravi.
Awesome. Thanks, Rohit. Now, the most common cause of cloud waste outside of having visibility set up is over provisioning of cloud resources. Now, this is because engineers care about performance and stability first and cost second. But this is also easy money on the table if you have the right tooling to see what resource sizing and configurations you actually need versus heavily over provisioning just to be safe. Now, getting the right tooling and then driving adoption of the tooling isn't always easy, but Harness CCM can help. So, our right sizing recommendations for Kubernetes workloads and nodes, ECS services, and VMs across AWS, Azure, and GCP give you the right tooling and everything that you need. So, let's see how this works. And Rohit, over to you for the demo.
Yeah, absolutely. So we offer like a wide range of recommendations. So I'll walk you guys through all the different type of recommendations, and we can drill into each. So the first type of recommendation is on Kubernetes workloads. So as you can see here, we've pulled in the configuration of what the current state is like, the current CPU requests and limits, memory requests and limits, and we have collected the utilization metrics of these workloads over time and plotted a histogram of all of the samples that we've seen. So this provides full transparency into what these recommendations are and how they are computed. And you have the flexibility to cover the percentiles, to change the percentiles on these graphs in order to reflect the changes in the recommendation. So as you can see here, the recommendation is to move from 2 gigs of memory to 1.3 and move from 500 millicores to 32 millicores. You can also set the quality of service and add an additional buffer in order to be extra sure as well. So the other type of recommendation that we offer is on the node pool level. So in this example, we see that there are 3 nodes of N1 standard 2, and there's an expected savings percentage of 76 on the specific node pool, and the recommendation is to move from 3 nodes of N1 standard to 1 node of E2 micro. And in order to facilitate like further tuning on top of this, we have a complete section to be able to tune recommendations, where you can add percentage buffers, or you can set the preferred minimum node count, or the largest workload that these node pools have to service. And we already pull in these information from the metrics that we've seen, but the users have the flexibility to modify these as well. And another common challenge that we see is the recommendations move instance families. So in this case, it's moving from N1 to E2. You can also set your preferred instance families to take advantage of the existing commitments that you have, or the underlying architecture of the workloads. We also offer a similar kind of recommendation for ECS services. Again, we plot a similar histogram like the Kubernetes workloads, and we can modify the percentiles by dragging on the graphs, and it will automatically adjust the recommendation. What we also do is VM recommendations. So this is an example of a VM recommendation that is in Azure. We also pull in the corresponding CPU memory metrics. And the idea here is that we provide a recommendation and provide the corresponding metrics to be able to support the recommendation, and for the developers to be able to look at these metrics and gauge whether the recommendation is valid or not, and go ahead and take actions. So in order to be able to take proactive actions on these recommendations, we offer what we call recommendation workflows. So you can move the recommendation from an open state to an applied state as you apply these recommendations. And let's say you find a recommendation and there is certain data points to not service that recommendation, you can move that to what we call as an ignore list. So once you add certain workloads and node pools to the ignore list, we will not show them as active open recommendations. We also have integrations to ticketing systems, Jira and ServiceNow. So for example, this is a Jira that has been created, it's been moved to the backlog, and it's going to be prioritized in the future sprints and be acted upon. So that's the different type of recommendations we have. And back to you, Ravi.
Awesome. Thanks, Rohit. Now, while over provisioning of cloud resources is arguably the most common cause of cloud waste, really cleaning up of often or unused resources is really the lowest hanging fruit to reducing cloud cost waste. Now, you just need visibility into which resources are unused across your estate. And doing this manually isn't the fastest way to do it, especially if you have multiple cloud providers and usage across many regions and cloud services. And that's where our feature called asset governance can help. Now, asset governance is an automated way to cost management, security, and compliance through simple YAML policies. Now, it works for any cloud resource, any configuration, and any kind of action. And we'll see this in action in a moment. But the power of this feature is in the breadth of its scope. Now, once you've cleaned up unused cloud resources, even for resources still in use internally by your teams, non production resources are typically idle and still costing you for three-fourths of the month. So let's look at the numbers here. So non-prod resources are used for about 4 to 6 hours of any given workday at best. Now, if you compare that to the whole 720 hours in a calendar month, that's just 25% of the time, which means that they're idle for 70 to 75% of the month, taking idle windows within the workday, non-working hours, weekends, company holidays into account. And static time based scheduling doesn't work because these idle windows are not always pre planned. And that's where our auto stopping feature, one of our binary differentiators, can help cut non prod compute costs by 70% on average. Now, auto stopping automatically detects whenever your non prod resources are idle and automatically shuts them down, but also brings them back up whenever your engineers need them. Now, activity is measured by various signals, which could be signals of usage such as network traffic, SSH, RDP sessions, and background jobs. And all of this is fully automated with no manual intervention. So let's look at both of these features in action. Rohit, over to you for the demo.
All right, I am excited for these two features. So let's dive into them. So this is our asset governance engine. So it's essentially a governance as code engine where you can define rules and policies to enforce on your cloud environments. And we have support for all three clouds. So let's take a look at what these rules are and what is the art of possible here. So here's an example of an Azure rule, right? So it's looking at and really like governance rule is three key things. It is any resource, any set of filters, and any set of actions. So in this example, it is just listing all of the Azure Cosmo DB resources which have low utilization in terms of total requests. And this is an example that is normalizing tags. So a lot of the times we see that there are multiple variations of the same tags, and we want to be able to standardize tags and retag or set these tags and make them compliant to the resources. So this is an example of a GCP rule where we are looking at all of the instances that are available on this particular project. We're applying a filter and normalizing this or these multiple variations of the tags to a specific variation. So this is actually going ahead and performing those actions in your environment, which would otherwise like take a lot of manual hours to be able to complete. So this is an example of the AWS policy that we have. And again, like it's acting on the EBS resource type, where we are checking if this EBS volume is actually orphaned. So it's not attached to any EC2 instance, which means it's orphaned, and we can actually perform the action to go ahead and delete it. So let's try and run one of these policies. So I'm going to pick an account and pick a region, and you can pick multiple regions. So we also have the functionality to run this in dry run because this involves a delete. I first want to check what are the resources that will be deleted if I actually run this in an active mode. So this will take about a few seconds to complete, but essentially it's going to fetch all of the resources. There we go. So it fetched one EBS unattached volume, and it gives you all of the information required about that volume to be able to go ahead and take actions. And we have a curated evaluation section where you can see all of the historical evaluations, and you also have the functionality and flexibility to create your own rules. As you can see here, some of these rules say AI generated. So essentially we have integrated the power of generative AI to be able to create these policies for you. So I'll show you a quick example. You can just choose which kind of resource you want to create a rule on. And let's say you want to create a rule on list S3 buckets where encryption is not set. So what this is going to do is it's going to generate the policy for you. And this is actually a quick way to generate this policy and like test it out in your environment. So the custom rules can get really complicated, and you can like create like a multi-step process around these rules. For example, this is a workflow rule that we have created around elastic IPs. So what we're doing here in step one is we are identifying any newly non-compliant elastic IPs, and then we are mock deleting these elastic IPs, and we are advancing these elastic IPs. So basically the workflow is that it will it will be in the state of ready for deletion for 2 weeks and send a notification to the developers. If the developers don't take any action to remove the tag, on week 2 it's actually going to go ahead and delete the unused elastic IPs. So you can create like a complex policy to orchestrate a workflow around it as well. And we also have a functionality of enforcements. You can run these rules one at a time, or you can sort of enforce these rules to run on a schedule, and it will keep running in, let's say this is in an active mode, and there are few rule sets which we are running in a dry run capacity at this point. So that's asset governance. So let's get to auto stopping, which is one of our binary differentiators. So auto stopping essentially is a way to automatically stop and start these resources instead of relying on static schedules. All that the user has to do is just access the website or the URL like they generally used to access. So here's an example of two auto stopping rules. One depends on the other. So as you can see, there is a UI, there is a rule which is fronting the UI layer, and there's a mid-tier layer. So I'm just going to click on this URL, and what it's going to do is it's going to automatically start these resources up in the background. So as this happens, as it warms up the resource, let's go ahead and take a look at the rest of the things. So here the mid tier is actually a dependency for the UI layer. So if I click into the mid tier rule, you can see that this is warming up. So essentially, when we clicked on the URL, it triggered a warm up for all of the dependent VMs and brought them up. So as you can see, this VM is now running. We have like a detailed view of how these VMs, how much cost we have actually saved on this VM over time. And these VMs are barely used because they're QA demo VMs. And as you can see, like most of the cost is in savings, and we have spent very little on actually running the VM. You can also see like detailed view of what this VM is, where it is running, the corresponding tags, and so on. So if I go back to the previous screen, we can see that this VM is also now up and running, and you can see similar metrics for the UI layer as well. And as you can see, the page has automatically started, and we can actually start using the page or the website as a user would regularly use it. Yeah, back to you, Ravi.
Awesome. Thanks, Rohit. And to talk about the coverage of these features, so we actually have asset governance available for all three clouds, AWS, Azure, and GCP. And from an auto stopping standpoint, also, we have coverage across multiple resources in all the three clouds. So we have auto stopping available for AWS, EC2 VMs, RDS, ECS, ASGs, and EKS. We have support for Azure VMs and AKS. And we also have GCP support for Compute Engine VMs, instance groups, and GKE. Now, we've been talking about the common causes of cloud based on the engineering side, but what about the financial management side of the house? And that brings us to commitments. Now, particularly AWS RIs and savings plans. So, what are the challenges here? So, the commitments are long term. They're either 1 or 3 year term commitments. B, there's room for human error if they're actually managed manually. And C, there are actually so many options to choose from. So how do you pick the right one? Just with AWS, you have compute and you have compute savings plans. You have EC2 savings plans, standard RIs, convertible RIs. With Azure, you have RIs and savings plans as well. With GCP, you have flex and resource-based cards, and then you have sustained use discounts. Now, our solution is to introduce automation to handle this, and the result is to maximize savings, maximize compute coverage, and maximize the utilization of these commitments. So there's no manual intervention with the de-risking of overcommitment using convertible RIs and compute savings plans for AWS that's fully built in. So let's take a look at it in action. Throw it over to you for the demo.
Yeah. Sharing. Okay. Yes, so this is our commitment orchestrator engine. So there are two key parts to it. There's the visibility aspect of how these commitments uh, are being used, how much have we saved, and what the compute coverage is looking like. So let's take a look at the visibility aspect, and then we can get into the automation aspect as well. So on the visibility side, as you can see here, this is the overall compute spend for the last 30 days. And we have broken this down by different sort of commitment types. So as you can see here, we have about 13K, which is about 50-60%, which is still on running on demand. There's a few reserved instances and a few and a bit of coverage on savings plans. You can also break these down by regions and see exactly what the percentage coverage looks like in each of these regions, uh, and get granular visibility into what is the RI coverage, what is the on-demand hours, what is the cost split between the on-demand and the reservation as well. And you can also do that by instance families. If you move on to the savings tab here, this is actually giving us the accumulated savings over time for each of these instruments of savings, like savings plans and RIs. How much have we saved from each instrument over time? You can again like group these by different regions, instance families, and so on. It also shows you like what percentage of these instruments are actually being utilized. So in this case, like there was a slight dip in one of these days, but everywhere else it's being utilized to its peak. And we also have like a detailed view of all of this across different types of group buys, and you can also choose to filter the scope of your view. But here comes the interesting part. So, how do you increase this compute coverage percentage from the 44% to X percent, right? And as you can see here, there's a call to action to say, hey, let's set up automation where we automatically purchase these RIs and savings plans on your behalf and maintain that compute coverage while de-risking any issues like overcommitting. So let's get into the setup. So as we get into the setup, you can select which master account that you want to run this orchestration on. And as we continue, we have a we have an option to exclude the instance types that you want, that you don't want us to take actions on or purchase RIs for your coverage. So for example, like let's say M5s are just being deprovisioned anyways, so we will just exclude these M6s from any sort of reservations or savings. So as we move along, what we now have is what is your target coverage percentage. So we auto recommend a target coverage percentage. So for example, right now we are at 44% and we want to increase our coverage to 70%. Or this is configurable, so you can, let's say, uh, go as high as 75% or 90%, all the way up to 100%. And this will automatically choose the coverage split between savings plans and RIs. So again, here, based on your historical spend patterns, if it's very static and and linear, then we recommend like a higher percentage of split on savings plans versus convertible RIs. And again, like this is fully configurable. You can choose to reduce the coverage using your savings plans. And we always leverage like 1 year no upfront savings plan strategy here. So as we make these choices and continue, what the engine would do is come up with an average, like a potential coverage at the end of the automation that happens, and what is the estimated projected savings after all these purchases have been completed. And we also have a review of the immediate set of actions that the engine will trigger, and essentially like once you click and submit, it's going to start the automation and start purchasing these instruments on your behalf to keep the coverage percentage at the target range that you have set up. And it also gives you a log history of all of the actions that it has taken over the history of time, uh, to keep a track of the auditability of what's going on. Yep, back to you, Ravi.
Yeah, thanks, Rohit. So the commitment orchestrator is really a great way to leverage savings through these commitments in a fully automated way. There's no manual intervention, and all of this is achieved through a combination of the compute savings plans and convertible RIs, like Rohit showed, that will address both the baseline part of your spend as well as the spend that goes up and down over time. Now, from everything that you've seen, we have one of the most comprehensive FinOps and cloud cost management platforms to offer. But to truly operationalize the adoption of the tool and FinOps practices at scale, it requires automation. And for this, Harness is in a unique position to deliver this value via FinOps automation with our years of DevOps background. And that brings us to what we call as FinOps workflows. Let's see how this works. Rohit, over to you for the demo.
Yes, let's do this. Okay, so I'm going to tie all of what we saw today together. So let's start with the perspective. This is a view of our sales team's costs and how much they're spending over time. And there's a corresponding budget attached to the sales team. So as you can see here, the sales team is forecasted to exceed the budget at the end of the month. And we want to take action to be able to keep their costs within the budget. So what we have done here is we have created what we call a workflow, a FinOps workflow. So this is an example of the previous run, but I'm just going to show you what this is looking like. So what this does is it puts everything in context of a series of events that will happen in a pipeline. So first it's fetching the budget details and it's checking if there's a budget overage. If there's an overage, it will trigger this cleanup workflow where it's actually going to find leverage governance under the scenes to first check if there are any EBS unattached volumes or like unused network interfaces, or this can like have like 20, 30 different steps running in parallel. In this example, we just have two, right? It's going to fetch all that, wait for that to finish, and then it's going to essentially massage that data in a presentable fashion. So, for example, it fetched all of the unused EBS volumes, and it is giving us context of, hey, like these are the volume IDs, this is the size of the volume, and this is the IOPS of the volume, just to give a sense of what kind of savings are possible. And it does the same thing for network interfaces as well. What we have in Harness is a huge step library where there are multiple steps that we leverage across our platform. So this is one of the steps that's first class. It's a Harness approval step. So we want the engine to find all these resources, but we don't want it to trigger the cleanup before a human approval. So in this case, we have added an approval step, and I approved this workflow to actually go ahead and clean up all these resources. And it actually went ahead and performed the cleanup again by leveraging cloud asset governance policies running behind the scenes. And what we also did was we sent a notification to the owners saying, hey, like your resources have been cleaned up, and all of the people in the user group who need to be notified. So this is essentially think of, and we also have the functionality to export these as what we call as templates. So you can essentially scale the same underlying workflow across multiple teams just by changing a few input parameters. So again, like we can look at another example of how this can be leveraged to automate recommendations, applying workload recommendations. So in this example, we're just getting all the recommendations and counting how many are there. And again, like because we have a lot of background in workflows, we have like some of these features like writing loops or doing like matrices in pipelines. So in this example, what we have done is we have found all these recommendations and we have triggered parallel executions to parse the recommendation. So as you can see, it's fetching what the P100 recommendation is, like the requests and limits for CPU and memory, and we're actually going ahead and applying the recommendation to actually go ahead and change the state of these workloads. And it has applied all of the 15 recommendations in parallel. And you can also choose things like concurrency to do it all at once as well. So this is an example of how we have leveraged our workflows to tie everything together and essentially do FinOps at scale, and also add like all of the customizations required into the workflow. So yeah, back to you, Ravi.
Awesome. Thanks, Rohit. Yeah, and as you can see, this is an incredibly useful feature to properly leverage the entire length and breadth of offerings that we have across FinOps and cloud cost management, which is really the key part. Like, one is evaluating which feature is the right fit for your use case, but also to be able to operationalize that and truly realize the value at scale and achieve that hard dollar savings requires a capability like this. So this can be incredibly useful. Now, as you've seen today, we've covered a whole bunch of capabilities that is still just scratching the surface. Now, we cover all the use cases required for cost visibility, cost optimization, and cost governance. Now, whatever your objective and use case is, whatever industry you're in, and however large or small your organization is, we have the right tooling and support available for all of your FinOps and cloud cost management needs. Thank you so much for joining today. And you can get started with our CCM product at harness.io. And you can join our FinOps Excellence community. Again, it's at finops-excellence.org. And we're happy to take any questions.
All right, super. Yeah, great, great presentation, great demos. And I had a question before we get into some of these audience questions. You guys have a great, view across a lot of customers, and I'm wondering what you find. I mean, how much typically do you find that customers are overpaying for cloud services?
Yeah, that's an interesting question, and we actually, I think we have a press release going out regarding this soon. The average potential savings from purely right sizing, basically, cutting down the over provisioning, was anywhere between 53 to 56%, meaning that's the amount that these cloud resources are typically over provisioned by, and this is across VMs, Kubernetes, all types of workloads. Typically, the containerized and the cluster over provisioning is higher, but that's really the average. So it's a very large number, and there's lots of
Wow.
savings to be had there.
Yeah, and you talked about the four key causes of overspending, and in which of those tends to account for the most, by itself? Is it the over provisioning?
Yeah, so the over provisioning is the most common,
Yeah.
and the easiest to achieve is just cleaning up unused stuff. But really, again, like, this is really dependent on the customer's specific use case. But in a lot of situations, if the non-production amount of spend share across the organization for the customer is large, then something like auto stopping with cutting 70% of non-prod costs. But it really depends on the specific usage the customer has.
Okay. All right. Excellent. We had a question here from Mike, who's asking: are Harness pre-built AI templates for vendors such as ServiceNow, Jira, etc., for idled, unused, and orphaned resources available to be individually tailored per use case to make specific recommendations?
Yeah, that's a great question, Mike. So essentially, like, we have two things available to be able to service this. So Jira and ServiceNow are first class integrations for Harness, and we auto populate the kind of descriptions that go into these Jiras and ServiceNows for the developers to have the right set of information to take actions. And when it comes to asset governance, like, we have a huge library of out of the box rules which you can leverage on day zero. But again, like, if there is a customization required, we have flexibility to be able to service that. And we also have AI generated rules to accelerate developing that new policy for your use case.
Okay. All right. Excellent. Thanks for the question, Mike. Next one here. Do you account for utilization spikes and startup times in your Kubernetes recommendations?
Yes, absolutely. So we have our own agent, which we sort of collect these metrics from, and we collect these metrics at a very granular interval in the order of seconds. So when we aggregate these metrics, we always look at the spikes in the CPU, also accounting for startups or any sort of like peak workload utilization durations as well.
Okay. All right. Um, what happens if a resource has been shut down by auto stopping, but a developer is trying to access it?
Yeah, so that's actually one of the key features or the key functionalities of the auto stopping feature is that it not only auto stops that resource, it also auto starts it, which means that even if it's currently in a shutdown state, scale down state, terminated state, auto stopping will bring up that resource in real time without without any manual intervention. And so the usage behavior for the end engineer doesn't change at all, even though auto stopping is managing that particular workload or resource and still resulting in savings. So there's no change in behavior and it's brought up in real time.
Okay. All right. And here's a question about reserve instances. I want to know, do you leverage standard RIs or convertible RIs?
Yeah, so what we leverage for the commitment orchestrator is essentially convertible RIs that has a lot of flexibility to make exchanges and all of those kind of modifications to de-risk from overcommitment. And there is no requirement to be able to sell it on the AWS marketplace, which is what the standard RI does. And so there's no risk of that being disallowed by AWS and things like that. So we leverage the convertible RIs.
Okay. All right. Excellent. Well, I think we've gotten through all of the questions there. Ravi, any, if somebody wants to get started with Harness or check it out or learn more, what are some of the things that they can do?
Absolutely. So the easiest thing is to log on to harness.io and navigate to the cloud cost management product. Anyone can get started right away. So that's the easiest way to do that. And on the FinOps Excellence side, it's finops-excellence.org. It's easy to join the community. It's designed for anyone who's a FinOps, CloudOps, engineering practitioner or leader. And so we'd love to have more members join.
Okay. All right. Fantastic. Well, Ravi, Rohit, thanks. This has been a fascinating presentation and great demos as well. Always appreciate demos to show the stuff, and really appreciate your insights here in the Q&A as well. Thank you so much for coming on and bringing us up to speed on Harness.
Absolutely. Thanks, Scott. Thanks, everyone.
Thanks, everyone.
All right. And our last piece of business is the Amazon gift card prize drawing. And the winner of the $250 Amazon gift card is Christopher Ryan from Texas. So congratulations to Christopher Ryan. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Harness for making this event possible. And thanks as always for attending and for your questions. That's going to conclude today's event. Have a fantastic rest of your day.